Imagine you kick a football straight up. How high will it go? How long will it stay in the air? How fast will it come crashing down? In this video, we'll use physics to calculate it all, step by step. Let's get started. Our tools are the equations of motion, also known as SUVAT. They connect displacement, velocity, acceleration, and time together. Remember that displacement, velocity, and acceleration are vectors. So we have to be very careful with the direction. We consider upward positive and downward negative. Now, before solving a problem about kicking the football upward, let's learn about some objects that are falling down. They are in free fall motion. What does that mean? It means the motion is under gravity only. So air resistance in this case is negligible. And we know that they have the gravitational acceleration of 9.81 meters per second squared and downward. Our first example is about a stone dropped from 20 meters. We are going to find the time it reaches the ground and the velocity before hitting the ground. I'm going to use two methods to solve this problem. The first one, we stick with our decision upward positive and downward negative. In that case, we don't have any initial velocity, 0. Our displacement s is negative 20 meter, and our acceleration is 9.81, but downward, so negative 9.81. Then we look at our equations of motion and we choose the right one. In this case, is the first one. We put the numbers in the formula, and here we go. We find the time. It's almost 2 seconds to reach the ground. The second method, only in this case, only when the object is just coming down, because acceleration and velocity are in the same direction, we can switch and consider downward positive, upward negative, or simply just ignore negative. The steps are similar, but we are not bothered with negative anymore. The answer is still almost 2 seconds time to reach the ground. For finding velocity of this object hitting the ground, I'm going to use the second method. So forget about the negative. Which formula do you choose now? The second formula is good. And we find the answer, which is almost 20 meters per second. Downward, of course. We can go to our original problem, which about playing with the football and kicking it upward. There is something interesting about when you throw objects upward. Can you catch it? At the top point, at the maximum height, they stop. So velocity at the highest point is 0. I'm going to use this point later. What about the time? The time of the object going up and coming back to the same level or equal of each other. We call that a symmetric motion. We are going to use this point solving questions as well. Let's get started. Our second example is about the ball kicking upward, speed of 20 meters per second. We are going to find the time to reach to the highest point, the total time of this movement, and the velocity coming to the ground, and the maximum height that it actually reached. First, now you have the initial velocity, and it's positive because it's going up. You cannot ignore the positive negative now. We stick to the upward positive, downward negative. So our acceleration is negative 9.81. Highest point, we learn that our velocity will be 0. So here is a list of the information we have, and we choose our equation. The second equation is useful here now. The time will be almost 2.04 seconds. What about the total time? As we talked about, it's a symmetric motion. So the total time is the double of the time going to the top, which is 2 times 2.04 and almost 4 seconds. What about the velocity of coming back to the ground? That's an interesting part. When you are coming back to the same place you started, your displacement is 0. Remember that displacement is a vector. It depends on just a starting point and final point. Your initial velocity, we already know that is positive 20 meters per second, and we want the velocity of coming back to the ground. We have the data, We choose our equations and we have the answer for velocity, both positive and negative 20 meters per second. Which one we should use? Of course, when you're coming down, it will be negative, downward. To find the maximum height, again, I go to the data I have. I have the velocity at the initial 20. I know that at the top point, the velocity is 0. And then I find the displacement. We can sometimes show it with H or S, doesn't matter. We choose our equations. Sometimes you have more options to choose from this list of equations. In this case, I chose the third one. And after calculation, the maximum height is almost 20 meters height. Remember to add these notes in your physics note. We know that for falling down, the initial velocity is 0. When you see the vocabulary dropped, falls, that means initial velocity 0. In this case, forget about the negative. Acceleration is g, which is 9.81. And you can rewrite equation of motion as a simpler form of S and V. But when you're throwing objects upward, you have initial velocity, and it's a positive number. Now your acceleration is definitely negative. At top point, we use this point that velocity is 0. So if I use equation of motion, again, I can have new formula, but they are not actually new. You just use this information to your formula list. Now is your turn. Let's have a quick quiz. Only 2 questions. Question 1. A stone is dropped from a cliff 45 meters high. What is the velocity just before hitting the ground? Did you get it right? The answer is B. The second question is throwing the objects upward with the speed of 12 meters per second. How long does it take to the maximum height? This one is the tricky one. Positive, negative matters. Use your formula, use the data that they gave you, and the answer is 1.2 seconds. If you like this video, please hit the like button and subscribe. Share it with your friends, and I see you in the next one.